Now, you've heard me say this kind of thing before, but an exception, as it says right here, is an abnormal condition. So in other words, when we're talking about an exception, it's an exception to the norm, meaning it's something you don't want to have happen. All right? It could be something as simple as you create an array with 10 elements in it, and you attempt to access element 11, something like that. All right? So as it says, it's one of the most powerful mechanisms for handling runtime errors. The big thing about exception handling, first of all, a lot of people don't like to use it. It really slows a program down, just so you know. Implementing it correctly can really slow down a program. All right? And I have mentioned this to you before, but the way that I look at it, there's basically 3 different ways to handle exceptions. All right? And the first way, again, I've said this to you before in other classes, is I just call it kind of the ostrich method. In other words, you stick your head in the sand and you hope that the person running the program never puts in bad data. And we all know that happens, right? No. You know, sooner or later, somebody either is just going to see what happens if they put in bad data, or accidentally puts in bad data, or fat fingers, you know, etc. They do something. All right? Another way that you can handle it, or you can handle it at least partially, is through the use of if statements or while loops, and we've done a little bit of that. For instance, when you put in the hourly rate, you had a minimum rate, you had a maximum rate, and if that hourly rate that was entered did not fall within that range, we reset it to a default rate. Is that what you want to do? I don't know. You know, it's going to depend upon a lot of things. All right? Now, in the stuff that we're going to go over in here, we're going to start looking at, for lack of better words, we're almost going to go nuts with exception handling. All right? And try to think of just about every type of condition we could run through. But when one of these conditions occur, how do you want to handle it? That's the big question. If it's bad enough that you use exception handling, then typically, not always, but typically the way you handle it is you have the program abort. And when you think about it, that's about as extreme as you can possibly be. Sometimes you want it to abort. If you are saying that your program has to use this file, and you give it a file, and you either give it the wrong file name or you give it a wrong path name, there's no file to use. All right? And if that's your input, you're dead in the water, for lack of better words. Or if it's a database and you give it a wrong location or a wrong name, that kind of thing. So typically, you would want the program to stop. All right? Do you want the program to blow up if you ask someone to put in, I don't know, the commission rate, and they put 300 in there, meaning 300%, which doesn't make a lot of sense, typically. But do you want the program to blow up for that? All right? That's a thing that, you know, given requirements by the people that you work for or the people you're doing the program for, they'll tell you. All right, so I'm just going to go through just a couple of these things in here. So it says their exception handling is a mechanism to handle runtime errors. Remember what runtime errors are. They're errors that are not found until runtime. Everybody hear that? It sounds simple, all right? But you may not know you've got an error in your program until you run the program, all right? So it's not a syntax error. And it's not a logic error. It's a runtime error. Now it says here, the core advantage of exception handling, what you'd like to do is to be able to handle the normal flow of the application. So in an ideal world, okay, in the example that they show on the screen here, you would want to be able to let them know they made a mistake or whatever in line 5, fix it, and go on and do lines 6, 7, 8, 9, and 10. That's what you'd like to be able to do. All right. Again, we're going to kind of blow this out of proportion a little bit and make it pretty big, just so you can see. And to be honest with you, when we get to the point of the driver, I'm going to give you not a hard copy. I'm going to give you an electronic copy of the driver. because my driver got up to around 500 lines. And I don't think you want to sit there and type that in. But every single thing I tried to do, I put in what's called a try-catch. Now, you've looked at some of this stuff, the stuff with try-catch. You've looked at it with C#. It works virtually the same way in Java, just so you know. All right. So, the reason that I chose this was not to waste time or anything else, but to let you know, under this hierarchy of exception classes, this is how it works, for lack of better words. So it says there the java.lang.throwable class is the root class of the Java exception hierarchy. What the heck does that mean? Well, when you take a look right here, what it says is every type of Java exception, really every type of Java error, is of type throwable. Now, you might say, well, who cares? There are two key words in Java. One is throw and one is throws. We're going to talk about what they mean in just a minute. But notice here the difference. You've got exceptions on the left and errors on the right. You can program for exceptions. Technically, you can't program for an error. I mean, if you run out of memory, what are you supposed to do? Especially if this program is running on a mainframe and you run out of memory, it's not like you can go and call a function that'll add more memory. It's not going to happen. All right? So the reason I'm telling you that is the stuff that's on the right here, that's over and above your control. So that stuff you don't program for. All right? So if somebody screws something up in there, you know, it's got to be handled probably by your hardware people. On the other hand, when you look under exceptions, anybody want to guess what I/O stands for there? Come on. I/O? Input, output. Again, that would come in anytime you work with files. I'm not talking about just databases. I'm talking files, whether they're input files, output files, or some hybrid. All right? You will have to worry about I/O exceptions, input-output exceptions. Why? You might call a file that doesn't exist. You might give a wrong path to a file. You might not have permission to write to a file. You might not have permission to read a file. All right? So there's a lot of different things that can happen. And the equivalent is what's down below. And that's SQL exceptions. So that's when you're working with a database. And the same kind of thing happens. Then you've got class not found exception. This can be a really big one because let's assume for a second that all 11 of us in here are working on the same program. All right? And I'm dependent on something, let's say, that Evan writes, and he hasn't written it yet. So I'm calling a class that doesn't exist. I can get a class not found error. All of these, notice they're under exception, but they're not technically under runtime exception. So I can probably figure these out before I even run the program, is what I'm saying. On the other hand, the ones that are here, I can't. So what's an arithmetic exception? Okay, trying to divide by 0 is an arithmetic exception. All right. What's a null pointer exception? Depending on how you set up a variable, if I were to say something like int age, okay, semicolon, or how about this, int age equal null. You can do that in Java. So I'm going to set age equal to null. Then I try to print it out. I'll get a null pointer exception. I'm trying to print out something that doesn't have a value. All right, as an example. Number format exception. The biggest one for that, for the number format, is I've got a field that I've defined to be an integer and I put a decimal place in it. That's a number format exception. All right? And then we've got a couple index out of bounds exceptions. And you'll notice that the one that you'd get more often is the first one, the array index out of bounds. And it's the one that I told you about. It's like if you've got an array of size x and you try to access element x plus 3, let's say. All right? And a string index out of bounds. So they do mention in here, and I'll send this out to you. All right? It says there are mainly two types of exceptions, checked exceptions and unchecked exceptions. Notice, an error is considered to be an unchecked exception. All right? But according to Oracle, and Oracle owns Java, there are three types of exceptions: checked exceptions, unchecked exceptions, and errors. So they go through here, what's the difference between them? All right? It says a checked exception. They directly inherit the throwable class except runtime and error. So they're ones, as it says, that are checked at compile time. All right? Unchecked are checked at runtime, but not compile time. So checked means that usually you can tell that you've got an error or something missing in your program even before you compile it. All right? But with unchecked, you don't know until you've successfully compiled it and run the program. Both of these you can account for as a programmer, both checked and unchecked exceptions. Again, the one you technically cannot account for as a programmer are just regular errors. They're considered non-recoverable type of errors, and there's three of them here. All right? Now, when you work with exceptions, guess what? You already know what try is. You already know what catch is. You already know what finally is, because we did deal with those when we talked about exception handling in C#, and it works the same way here. So as it says, what is try? It's a keyword used to specify, in between the try, you put in a block of code, so it's within curly braces, and you put in code that can conceivably fail. It may not fail at all, but it could conceivably fail. Okay? After you put in a try, you must put in either one or more catch blocks or a finally block, or both. All right? Normally, it's called try-catch for a reason. You put in a try, and you put in one or more catch statements. The finally that we'll look at in just a minute, it's typically for housekeeping operations. So try is where you put in your stuff that could conceivably fail. Catch means if it does fail, how do you want to handle it? And we did talk about this with C#. Works the same way with Java. You've got to put the errors that are most specific on the top, and the ones that's are least specific on the bottom. The least specific type of exception in Java is type exception. Java will go and flag things as being exceptions a lot of times, even if you don't consider them to be. But if you have type exception in your code, it must be the last one in the listing if you've got more than one catch statement. All right? And then finally, no pun intended, the finally block is done for housekeeping. So in other words, now maybe it's time to close the file, it's time to close the database connection, or whatever. All right? Then there's throw. It says the throw keyword is used to throw an exception. Okay? There's two ways that exception can be thrown. You can throw them, or the system can throw them. If you throw them, you can write your own exception handlers. If the system throws them, typically they will call built-in exceptions. Did you all hear that? All right. Now, if I go out, and I'm not going to spend really any time on this, believe me, but I'm going to just type in here Java API exceptions. All right. And I'm going to click on here. And the funny thing is, it's still running really slow, but I managed to clean up 24 gig worth of stuff. Still running slow. Can you see all these right here? These are the built-in Java exceptions. But let's pretend for a second we're writing, we've done this kind of thing. I think we did it back in the days of JavaScript. We're doing a simple miles per gallon program. All right? And we say that the minimum miles that you can drive are 1, and the maximum miles you can drive, let's say on a tank of gas, is 1,000. I'm just making those numbers up. And you want to use exception handling. Well, if somebody enters in 10,000 instead of 1,000, that's too many miles exception, or too many, miles input exception, or whatever. That's not in here. So if you don't want to use one of the actual built-in exceptions, you have to create your own. We're going to do that in just a couple minutes. All right? And throws, as it says, is used to declare exception. Throws does not throw an exception. Throws says that a certain method can possibly throw that kind of an exception. All right? And I'm not saying, does that make sense? Maybe it does, maybe it doesn't. All right? Now, when you look on the screen here, this is very similar to what we've looked at in other languages. Notice line 5 is a statement that will break because you're taking 100 and you're dividing it by 0. You know as well as I do the answer to that is infinity, which although Java can give you the word infinity, all right, I'm sorry, JavaScript can give you the word infinity. Java doesn't do it. All right? So you're going to get one of these arithmetic exceptions. So notice inside of the try, you put curly braces and one or more statements that can conceivably fail. All right? For catch, this is an exact error that you're looking for. Arithmetic exception. We're going to call it E. Doesn't mean anything. You can call it anything you want. And if we get that error, we're just going to print out all of the information associated with it. Does that make sense? All right. That's just how we're handling it right there. And we're going to go on. Now, can you do more than that? Yeah. You can go back in the catch, and you can say, hey, you screwed up. I'm going to take, instead of that being a 0, I'm just going to return 0 as the result. You, as a programmer, have control over what happens when an exception is thrown. All right? So you'll see something that looks like this. You got an exception under java.lang. It was an arithmetic exception. All right? And they give you a couple scenarios. Again, dividing by 0, what I mentioned before, the null pointer, a number format exception. Notice this, because believe it or not, this is the kind of thing we have to account for in our payroll program. If we say string s, let's pretend for a second, we're not doing it this way, but let's pretend for a second that what we wanted to do was, in fact, we don't even have to pretend. If you remember, we did something like this. All right, we did something like this earlier, where when we used the message dialog, we did something almost just like this. And I mentioned to you at that time that if you went in and you entered, for instance, if it asked you for hourly rate, and you left it blank, or you typed in hello, all right, let's say you typed in hello instead of ABC, and then we did this. The system is trying to parse this or convert the word hello to an integer. It doesn't know how to do it, so it'll break. All right? In array index out of bounds, I've already mentioned that to you. Okay? So like I said, I'll send this out to you. You don't want it, throw it away. Now, this is a little bit redundant, but I just want to quickly, there's another thing that I found in here under how to specify and handle exceptions in Java. The bad thing when you look online and you start looking for articles about exceptions is this is what happens. Let's see. When you have exceptions, the system will come in and say try, okay? And then when you have a catch, what it will do is it'll put a comment in there that says, now do something. It doesn't tell you what to do. It just says, put your code in here that will handle that error. That's not really very descriptive of what you'd want to have happen. All right? But last thing I'll tell you, because this is all I'm showing you on here. If you look on the screen, in this try, this is all made up, okay? But the point of this is, it must be that the My Business exception must be a more specific exception than this one. If you flip them, then number would always happen and you'd never get to My Business exception. Again, the last exception that people typically put in there, if you want to, is just one that says exception E. If you put that first instead of last, that'll always be called and you'll never get to your exceptions. You do exception handling like this so you can let the user know not only that they made an exception, they have an exception, but the kind of exception that it is. All right? I've written programs already with literally, you might have 2 or 3 pages of catches. There might be 30, 40, 50 things that can go wrong. In a lot of these programs, they're designed that, okay, that error happened. All you do is you log the error and you go on. But somebody eventually looks at those logs and says, hey, we've got a recurring pattern here where this is being screwed up. All right? All right, and I told you about the finally. Okay, typically, like I said, you'd use it to close. I'm not going to go over the try with resource. Okay. All right, I think that's enough. Now, we didn't really have a break, so let's come back at 5 to 3, and I'm going to show you, we're going to start getting into this today. All right? I'm going to do the best I can to get as far as I can today. Yeah, we'll actually go pretty much till the end of the class. And because I want to finish this by tomorrow and still give you some time to work on a pretest. Bottom line is this. I want us to do a test on Monday. Why? So Tuesday we can start Android. Then the rest of the semester will be Android. All right. My goal is to lecture Android Tuesday, Wednesday, and Thursday. Friday, give you some stuff to try, and give you each a tablet. See if you can connect, create one or more simple apps, and actually run them on a tablet. All right. So please, it's 2:41. Let's come back at about 2:55.